Welcome to Key Concept 7. This is target A. Your goal is I can use Pythagorean Theorem to solve for missing sides of a triangle. So before we get into this new thing of Pythagorean Theorem and what that's all about, I just want to go over what a triangle is in case you forgot. Now, you're probably very young when you first started seeing triangles. Maybe you got some blocks as a kid. But a triangle is a two-dimensional shape with three sides. So if you look at each of these shapes, you count 1, 2, 3 sides, 1, 2, 3 sides, 1, 2, 3 sides, 1, 2, 3 sides. So they have three edges that make this kind of pointy shape here that we know as a triangle. And you've probably seen a lot of triangles throughout your life, but they're a very, very important shape in mathematics. So we want to look at a very special type of right triangle. That special type of right triangle we're going to look at is called a right triangle. Now, that doesn't mean that there are left triangles or wrong triangles or anything like that. We just want to look at a right triangle which have a right angle in it. Every single right triangle has a right angle in it. And it's this angle with this little square in it. It has this little square in the corner here. That means it's 90 degrees. Super important number, the 90-degree angle here. It's one of the most important angles in all of trigonometry in the greater world of mathematics. It's a super important angle. So if you see that right angle, think 90 degrees and then think, okay, it's a right triangle then. So your rule, how we're going to tie this back here, is that if a triangle is a right triangle, you have permission now to use the Pythagorean theorem. So what is Pythagorean theorem? It's what I set up here as the objective for today. So Pythagorean theorem was invented, popularized by Pythagoras, who's debated on whether or not they were a real Greek mathematician, but there's the Pythagorean Society, and they actually kind of stole this, or at least there's evidence that Chinese mathematicians were using this before them. So here is the Pythagorean theorem. It is a to the power 2 plus b to the power 2 is equal to c to the power 2. And this only works for right triangles. So, and it's important to note that the side labeled c is always directly across from the right angle. So here is just a standard triangle where a, b, and c are the side lengths. It's a right triangle. So you can say that a to the power 2 plus b to the power 2 is equal to c to the power 2. Well, let me show you an example to prove that this works, right? So here we have side 3, side 4, and side 5, and it's a right triangle. So 3 is in the a spot, so I'm going to say 3 to the power 2 plus b is in the 4, or 4 is in the b spot. And then across from the right angle, right, if I were to draw an arrow out from this right angle, it's 5, right? So I'm going to say is equal to 5 to the power 2 then. Well, you could take out your calculator. If you know your squares, you probably got this. 3 to the power 2 is 9. 4 to the power 2 is 16. And 5 to the power 2 is 25. Remember last semester when we did a lot with squaring? Here's where it kind of comes in. So 9 plus 16 is 25. And 25 is equal to 25. That is a true statement. So the Pythagorean theorem works. Now, how can I use that to solve for missing sides? Well, look at this example here. Here I have this side 4, this side 6, and then this missing side C. Maybe I want to know how long this side C is because it represents a railing on a staircase or something. So, well, let's see here. 4 is in the A spot, right? And then 6 is in the B spot. So what I'm going to do is I'm going to say, draw a line here. 4 to the power 2 plus 6 to the power 2 is equal to c to the power 2. So here's where I can go ahead and now solve, right, and reduce things. So 4 squared is 16. 6 squared is 36. I can add these together. 16 plus 36 is 52. That's equal to c squared. Well, now I could find c, right? I have c squared. I want c. The way that I do that is by taking the square root of both sides. So if I go ahead and I open up Desmos, and I take the square root, 52, 7.21111. Let's round that to 2 decimal places. So I'm going to say c is equal to 7.21. That is how big this side is, 7.21 units.